already mentioned about the Erratic, where we say it's a large boulder of rock which has been transported by a glacier. Then we have the series of Erratics being obtained from the same bedrock, being deposited with the apex pointing to the origin of the material, then that becomes a boulder train. Also note they can occur in a linear form, and they are found in the limestone Craven district of Western Yorkshire in England. Let's see how that looks. Look at that. Have different boulders being deposited by the glacier. So yeah, that is it. Another deposition feature is till, also known as boulder clay. We have till, which refers to the unassorted mixture of rock, clay and sand. It's carried on the surface within or below a glacier or ice sheet and is deposited directly by a glacier. So once it melts, it will get to deposit the unassorted mixture of rock, clay and sand. So its composition may vary greatly depending on the source of its materials and the area over which the glacier has traveled. So there are various types of tills. We have ablation till, lodgement till, and basal till. So let's start with lodgement. This is identical to ground moraine. It's the material that is smeared onto the valley floor when its weight becomes too great to be moved by the glacier. So we can say ablation till is deposited when the ice melts. Then we have ablation till. It's a combination of englacial and superglacial moraine. It is released as a stationary glacier begins to melt and the material is dropped on site. On site is what we call in situ. Then we have B for basal. This is till that is formed when the lower debris, which is rich in those tills below the ice sheet, are forced to move slowly. Basal, we're talking about movement. So most likely the obstacles resulting in their ice leaves them behind. So for the tills, you can use lab. L for lodgement till, A for ablation till, then we have B for basal till. And remember, the till is usually responsible for even some of the beach formation on what is deposited. Like here, you can see the ablation till. Look at that. Like this one. This is till, there's a mixture of rock, clay and sand. So for the till plane, they are formed when the till covers the ground, and it can be irregular in shape, the landscape. If the area happens to be a highland, a flat highland, then the ice sheets cover on top. That would be a till plateau, for example, on top of former hills and valleys. Once they are covered or buried by the till, they will form till plains and till plateaus, like what you can see down here. Another feature that we have are drumlins, and this is a long egg-shaped hill of glacial till, which is shaped under an ice sheet. So the drumlins occur on till plains in large numbers. That is, they occur in groups, and they form beneath the ice due to friction between the bedrock and the boulder clay, resulting in deposition of the till. Remember, we were saying that for deposition to occur, sometimes there must be friction. So due to that resistance, there is dropping of materials, that is till, at the bottom of the ice. With more deposition, a large amount of till deposits are formed. The moving ice streamlines the till that had been deposited irregularly, resulting in the upstream side of the till being steep and broad but smoothed. So the downstream side will be narrow but elongated in the direction of ice movement. And they're common in North England and North Ireland. So look at there, it's egg-shaped, you know. You can see they're saying they are found in groups called drum fields or drumlin camps. And they are products of the plastic deformation of ancient glaciers. So you can see they are egg-shaped. Looks interesting, right? Yeah, the drumlins. Long egg-shaped hills deposited and shaped under an ice sheet of a very broad glacier. Like, look at those hillocks of gravel, clay, and sand that were deposited on Wednesday area. Those are drumlins. You can see they are egg-shaped. So that's how drumlins look like. So you can see it's so different from Aroshe Motini, you know. Like this. So we can say that drumlins are elongated teardrop shaped hills of rock, sand, gravel that form from the movement of ice. And they are typically oblong, that is to mean 2 or 3 times longer than they are wide. And it comes from a Gaelic word dream, to mean back or ridge. Then we have an Esker, and now you can see it. So it's a long winding ridge composed of gravel formed by glacial deposit. The streams carrying large amounts of load flow fast in a subglacial, like the ground tunnel, parallel to the direction of the moving ice. When the ice melts, the tunnels collapse, causing the streams to slow down and deposit much of the load, forming a ridge. So that's what you call an esker. Yeah. So you can say an esker, which is an Irish word, unlike the term drumlin that was Gaelic in nature or origin. These are sinuous ridges of sand and gravel deposited within tunnels carved by great rivers at the edge of the ice sheet during the last glaciation. And this word has been incorporated into the world scientific literature. I mean, that's the beauty of linguistics versus geography. Yeah. So you can see the esker there. Like this is Kinyalu esker in Finland. You can see plants got to grow on there, and it's forming beautiful autumn colors, isn't it? It is giving. Here it's in Haraju in Finland. Look, the brown. The brown is the... So an esker, as we have said, is a long winding ridge of coarse sand and gravel formed by streams that flow continuously beneath or within the ice, but roughly in a parallel direction to the moving ice. That is to mean they almost don't meet. So if the ice remains stagnant for a long time, the streams form permanent glacial tunnels. So the water flows through such tunnels under hydrostatic pressure, making the flow to be rapid, hence the amount of load carried to be quite large, because there will be that erosion happening, and the materials will be quarried out. So when the ice melts, the tunnel will collapse and the streams will slow down, and much of the load will be deposited to form ridges of deposits. So eskers range in a length from 10 of meters to hundreds of kilometers. They can also wind up and down the hills across the landscape. Some are branched while others are single features. Like this one was a single feature. The previous one I showed you was branching out. So eskers are similar to moraines, but they are stratified. As you can see, there are different layers, and some eskers can also be formed by rivers that merge from a retreating ice front, so that the deposits become longer as ice retreats. Word of the day: esker. This is a long winding ridge in a landscape left by the deposits of meltwater that once flowed beneath a glacier, and it's a subtle word for rare and enigmatic landform. It's got from an Irish word Esker, aka os, or serpent, Kame. So you can see it's there. That's an osar. Like this is an aerial view of a partially drowned esker in Sweden. Like you can think it's a snake. Literally, it looks like a snake. Do you like it? Oh, it looks like the head of a snake. So that's an esker. Esker was a ridge. It's winding, it's taking that snaking shape because rivers usually do have the meanders. So you can see. So we have a stream there passing beneath a glacier. So yeah, that's how it looks. Once you look at the Kame, a Kame on the other hand is an isolated hill of sand and gravel which have been deposited in strata by glacial water. So that's the Kame. So you can see it's isolated. Some Kames seem to be old deltas at the margin of the or front of a subglacial stream, and they are formed at the margin as they are called marginal kames, because they are formed at the edge. When the ice supporting the material melts, the kame collapses, forming a steep-faced hill. So some kames are formed from the accumulation of deposits in crevices on the ice surface, and they usually do vary in size and shape. They can occupy in groups or single. Yeah. Then sometimes deposition of sand and gravel may occur in narrow lakes that exist between the glacier and adjacent highlands. So such deposits in the formation will lead to formation of a kame terrace like this one. So the features are similar in formation to lateral moraine ridges. So kames are mounds of deposit that are scattered over outwash plains. They are built up by the streams at emerging high levels from temporary stagnant ice fronts in the same way as alluvial cones. They form as steel is washed into holes at the glacial front recedes. So we have those mound-like hills known as kames. So we can look. You can see there was ice moving, then it became stationary. The rivers that were beneath formed an esker, then there is hillocks formed. Yeah. Another feature is kettles. So kettles, these are glacial depressions produced when large ice blocks stuck in the glacial alluvium melt. The diameter of such depressions range from 5 meters to 13 kilometers with depths of up to 45 meters. And most kettles are circular in shape due to melting blocks of ice being rounded. So we are seeing that for these kettles, they are technically shallow depressions formed when a portion of the glacial ice is buried by layered drift. So there will be stratification within that area. How do kettles form? The depressions form when the block of ice melts, so that the sediments collapse into a kettle. The lakes that often, if water fills into those depressions, the kettles, they'll form what is known as kettle lakes. So yeah. So there you go. Those are kettle lakes. Like sometimes there you go. Those are kettle lakes. Yeah, that is a kame and the marginal kame. Outwash plains, like this is a good example. So this is an extensive area formed when finer materials of terminal moraine are deposited in very thick layers over a wire. So we can define outwash plains as wide, gentle sloping plain composed of gravel and sand formed by glacial deposition. how do they form? Wanna see that in a few. So we can get to say that outwash plains form when ice melts, so it drops most of the load that it was carrying at the terminus, like at the end of the glacier. So the melting ice provides large quantities of water that carry the moraine further ahead while sorting it out, so that we'll start with the heaviest towards the lightest load. And this will be deposited extensively on a lowland to form a plain. So the heaviest fragments of coarse gravel are dropped first near the ice margin, while finer particles, the materials can go further away. And these include clay. So the fluvio-glacial materials are spread out far beyond the ice front and laid to form very thick layers. The streams on an outwash plain form braided channels because during winter the amount of water from the melting ice is less, resulting to deposition of fluvial materials. The materials block the stream channel, causing it to branch into various channels. Yeah. Look like here we can see the rocks, then the finer sediments towards where the polar bear is. So there you can see the glacial outwash plain. The final feature that we want to look at is terminal moraine. So the terminal moraine ridge is a ridge-like feature formed by extensive deposition of moraine along the edge of an ice sheet, like at the terminus. So the ice remains stagnant for a very long time. So because it's stationary, the ice at the edges will melt and a lot of materials will be deposited. Remember, when it's stationary, there is accumulation of more ice, so there will be that pressure that will lead to melting, that will cause dropping of materials. Due to the melting. So we can say that a lot of materials are deposited, and the terminal moraine may extend for several kilometers with its height, depending on the length of time the ice front remains static. The more it is stationary, the more the height will be. Here. So you can see the loop usually will end up being so rugged that it cannot be utilized for farming. Hence, it will be covered by native forests. Yeah, like you can see here. Then you can also see the braided channel. The braided channels across the outwash plain. When the amount of water is less. Like this is the Wayo loop, which is made, and it's semicircular. So there you can see it. A series of nearly parallel terminal moraine ridges, known as recessional or stadial moraine, may be formed when the ice sheet retreats at intervals, meaning that each stadial moraine marks a period when the snow line of the ice was static. So you can see we have the recessional moraine here. So this was the first one, second one, third, So it's parallel to the terminal moraine, and it's used to show the recession, like A recession happens when there is melting. Yeah. So you can see the terminal moraine. Like this is the terminal moraine of the Ruth Glacier. I'm so happy there's a glacier named after me, Ruth Glacier. Then look at the middle ground of the photo. You can see the recessional or stadial moraine. Yeah. Which is a series of parallel terminals. Yeah. Let's show the edge. Like you can see this one. Then it will go here, there as it continues to recede. So water flowing from the ice front of a retreating ice sheet, like it's going backward to its origin after melting, may be blocked by the terminal moraine, and it accumulates behind the terminal moraine to form a lake known as Moraine-dammed lake. Moraine-dammed lakes. So you can see after melting it will start to retreat back. For the moraine-dammed lakes, so we know a lake is an accumulation of water occupying a basin or a depression or a hollow. So you can see like that moraine causes a wall, and when water accumulates behind it, it is what we shall call a moraine-dammed lake. Examples are the Great Lakes, that is Huron, Ontario, Michigan, Erie, and Superior, due to blockage by terminal moraine. So there you go. Like this is Lake Superior. Beautiful. I hope you enjoyed. Bye.